Happy Monday, 8th grade. I hope you all had a great weekend. Today we're going to start by talking about local and global wind patterns. So let's start by talking about these global wind patterns. So the global winds also occur because of uneven heating on a very large scale. So because of the uneven heating, the equator tends to warm up much faster than the poles do. And this is why the equator is one of the warmest. Like if you go towards the tropical regions, it's warmer than the areas in the poles. The wind moves around the planet because of the differences caused in air pressure due to this uneven heating, and they do not move straight up because of the Earth spins on its axis. So instead of these lines going straight, you'll notice that they're curved. And the curve of this wind is something we call the Coriolis effect. And there's two sets of each of the following global winds. So at the poles, we have something called the polar easterlies. So these are these regions below this yellow line. And you have these polar cells. And these are the cooler regions. And then if you move towards the equator, we have the prevailing westerlies. And you'll notice that those are both in between those yellow and the purple lines. And then towards between the temperate and the tropical zone, you have these trade winds. There's also two really calm areas that we're going to talk about, and those are the doldrums and the horse latitudes. So the doldrums are right on the equator between the trade winds, and it's that pink line you see in the middle that's labeled with the green subheading. So you see this line right here, and this is the doldrum. And then if you go to the lines to the outside of that, past the trade winds, now you're in the horse latitudes, and these are also very calm areas on the horse latitudes as well, where you have this kind of shifting of direction, so you get this more stagnant area. So we're going to move on to start talking about local winds, and we're going to talk about land breezes and sea breezes. So anytime you talk about a land breeze or a sea breeze, what you're talking about is what the direction of that cool air is. So during the day, you'll notice that the cool sea breeze is coming off of the cooler air is coming off of the ocean, and therefore this is called a sea breeze. So you have this cool air, which is denser in this air, sliding in underneath this warm air, which is less dense, and it creates this circle or this convection current. And then you'll notice that during the nighttime, we switch to a land breeze. And so you have this land breeze, which is the cool air, which makes it the land breeze, sliding off of the land, going towards the sea, while the warm air over the sea rises up and moves towards the land. So the sea breeze, during the day when the sun is up, the land heats up very, very quickly, and the air above it warms up a lot faster than the air over water. So the air over the land is going to heat up much, much faster than the air over water. And if you've ever been out into the ocean, you'll notice that it's a little bit cooler the further you go out away from the land. The warm air over the land is less dense, and it begins to rise up, and you get this low pressure system that's created, and the air pressure above the water is higher, and it has a cold dense air, and this is why we have this sea breeze then, as this cold dense air comes to take the place of that warm less dense air as that rises up. So the cool dense air moves in to occupy the space created over the land where that warm air heads rose up. And the cooler that comes along, this is called a sea breeze because the cold air is coming off of the sea, and therefore we call it a sea breeze. So when you think about the word breeze, when you're talking about these local winds, I want you to translate to figure out whether it's a land or a sea breeze is where is the cold air coming from? So you see here we have this cool sea breeze moving towards the land during the day. The warm air is rising, creating this low pressure. And then we have this high pressure coming in to take the place of that warm air that's now rose up. In the night, The reverse happens. The land really quickly loses its heat while the water retains its warmth. So it's harder to move to change the water's heat 1 degree Celsius. It's much harder. You need a lot more energy than you would if you were to change the air above the land. So now we have the reverse happening. So this means that the air over the water is now warmer and less dense. So this is begin to rise, and the low pressure is now created over the water instead of the land. The cold and the dense air over the land begins to move towards the water surface to replace that warm air rising because of the pressure system moving through. So now we have the breeze from the land coming in, and because that cooler breeze is coming from the land, we know that it's called a land breeze. And this is a diagram of that, and you see this cool land breeze moving towards the sea while this warm air rises up with this low pressure, and it's less dense, and it comes towards, and then it will cool down, and we have this going on during the nighttime. I want you to go ahead and move on to your packet where you're going to draw these breezes and show us what is going on, and then answer some questions about these land and sea breezes. Next, after that, I want you to move on to practice your Quizlet terms to start reviewing for your benchmark.